Here we were looking at the conversion of all the other elements alongside the pivot column to be zeros, apart from the element corresponding with our new entering what? A variable, which we'll be using it actually to convert all the others to be zeros. So I'll start by, let's take a look at our previous table. Our second table, we want to convert this 3/5 to be 0 using our new law C2. So what do? Here we have our new law C2, which we have found to be 0, 1, minus 0.5 all the way to the right-hand side element. And we want to use this one here, this is our important point, to convert anything else that will be alongside that particular column, which are calling the pivot column, to be equivalent to 0. So I'll start with the law C1. Law C1, we want to convert this 3/5 to be a 0. So how can I use this one to make this 3/5 to be 0? I just multiply it by 3/5. Don't have to complicate my work. And at the end of the day, remember, whatever you're doing to the left, you have to do it to the right. And so after I've multiplied my whole of my old law C2 elements by 3/5, I end up having this particular element. So I'll take away to be able to create a 0 here. And remember, whatever you're doing again to the left, you also do it to the right. So now I have a new value for the C1, which is coming to 4250, that can be read on the right-hand side value. The same I've done to law C2. Law C2, we had a 21. If you are to go back to the table 2, this was our table 2, we convert this 21 to be equivalent to 0. Again, I'm still using my new law C2 elements. And to make this 21 to be 0, because on my C2 I had a 1 here, I just multiply by 21. Again, don't complicate your work. And you'll have created a 0 alongside that particular column. And the same I've done to my law Z. Law Z, I had 0 minus 157. This is what we want to convert to be 0 at the end of the day. So what I've done, on my C2, there was a corresponding element 1 here. I've just multiplied by 157, so that the 157 here and this 157 that I've created can allow me to create a 0 at the end of the day. Then because this is a minus, this is a positive, what I've done here is just to add. I should have indicated this positive sign here, that I'm adding these two to be able to have created a 0 here at the end of the day. Now, what do? We observe the last law that we are calling law Z, and what we see are all elements being positive. I repeat, all the elements are now positive. You can see there is no negative element. All these are actually positive. And it's out of us seeing positivity of the elements alongside law Z that allows us now to actually talk about creation of the last table. We call it the final table. And the final table is going to be given by the new elements that we have seen in the previous step. And we just bring them into our table. This was our C1, whose elements are now like this. The S2 law, whose elements are like this. And finally, we have our law Z, whose elements are like this. Now, because we see no negativity on our law Z, then we can say the solution of 4,441,000 there is actually an optimal value, and so the solution to the problem. If we had some negatives here, we would have said the solution is not optimal, but for us, then we can say an optimal solution has been reached to because all elements alongside low Z are all positive. Then the solutions to the C1 and the C2 are what? The number of chairs for C1 model are 4250 chairs. The number of units for C2 model chairs are 4250 chairs. And finally, the solution of the Z is 4,441,000. If you still want to do the substitution in your objective function, you still can do that, and you'll have the same value arrived at that is the same as to what you'd have found from the table. These two should actually be the same. This is the number of chairs for C1. You can read the C1 is equals to what on the right-hand side. C2 is equals to what? The 4250 units given. In my last example, I said, yeah, here comes a solution to the problem that you read on the right-hand side of our Z law. Then these figures are interpreted as what? The 32.5 is the shadow price for machine X hours because the S1 was corresponding to the first constraint, if you remember, that was about the machine X hours. Then the C2 was the corresponding, yeah, slack variable for machine Y hours. And you can see we have a balance. This S2 here is equivalent to 22,750, yeah, meaning we have not exhausted. And we said for a resource that is not exhausted, then the slack variable is usually 0, and we don't pay, or rather the slack variable is not zero, sorry for that, and the shadow price itself is 0. I repeat, for a resource that is not exhausted, a slack variable will have a value, but the shadow price will be equivalent to 0. So the shadow price for machine Y hours is actually equivalent to 0 here, which you're able to read it comfortably from your last table using the simplex method. Then again, the slacks for that is the machine X and the plastic waste, the S1 and S3 are actually equivalent to zeros because those ones have actually been exhausted. There is no balance at all. If there is a balance, you read it on the right-hand side, okay? But if there is no such a value, then it means the slack is 0, and that means you have already exhausted the use of that particular resource, which means you have to pay a price in case you want to have any additional amount, and that is what we call the shadow price. So our interpretation here would actually mean what? For us to use an extra kg of the plastic waste would be required to pay 98 shillings and those cents there. If we want to use an extra hour in relation to machine X hours, then per unit would actually pay this amount of 32.5. But for the machine Y, no payment will be required because we haven't even exhausted the production of 4250 and the 4250 again for C1 and the C2 respectively. Now, how would we relate our solution so found in our simplex method here to what was given in the problem as the computer solution provided in that example? Let me take you back to the interpretation that I did. This is what we now call the sensitivity analysis. After we formulated the LP in my computation, page 2, I was interpreting the figures that were given, but I wanted us to see the comparison we can make actually from a simplex method. What is the contribution per a unit of, let's say, C1 and the C2 chairs? And these are the figures given actually as the objective coefficients. You can see this one from the data given in the question. The objective coefficients, the coefficients of C1 and the C2 are 555 as well as the 490. And if these were not given, you should be able to compute like what we did using the contribution given by the price per unit minus the variable cost per unit. Then you can also see the values of the C1 and the C2 given in the solution. Again, the 4250 values of the C1, C2 are the corresponding figures we have even found using our simplex method. So if we were not given the objective function value of 4,441,000 there, is it possible for you to come up with it? Yes, because after you have formed your objective function, you should have, for example, picked your coefficients for the C1, C2, multiply each by the corresponding numbers, that is the C1, C2, 4250, and finally you should arrive at the figure of 4,441,250. Okay, then what is the meaning of the increase and the decreases? If we were to increase the C1, I repeat, the units of not the units, but the coefficients, sorry, the coefficients of C1 and C2, we increase that one of C1 by 261, and we also reduce by 65. What is the meaning of this is that the objective function value will not change. Would expect the figure to remain the same with the allowances provided if the coefficient of C1 and that of C2 were to change by the given remit, say by increasing it or even declining these two. At the end of the day, the meaning is that the decision, or rather the decision made, will not have interfered with the objective function value. Also, you can see, and here I would want to make a small correction, the values given, plastic waste, we have used how much? We have used 34,000. How? If you are to go back to the constraints here, class, you can see the plastic waste, we were having 4 units of kg for C1, 4 kg for C2. If we were to come back and you substitute 4250 for C1 and C2, you'd arrive at a figure of 34,000. We have exhausted, there's no balance. And if we have exhausted, then we can pay a price, we are calling the shadow price per unit of any extra unit we want to obtain from the market. So the values given for the plastic waste there, that is what has been used in the production of the 4250 units of the C1 as well as the C2. Also, machine X. If you are to substitute the 4250 here, C1 and the C2, you realize that you come and fix the 4250 here, you realize that the figure of 3,400 hours will have been exhausted. There's no balance. So if you are to obtain an extra unit of that, you'd pay how much? So I would wish to make a correction there on the question from the past paper. That figure of 325 ought to have been 32.5. 32.5. I suppose it's a typing error. You can make a correction there. Then finally, for machine Y hours, how much have we used? If we come to machine Y hours, you fix the values of 4250 C1, 4250 C2, you will not have exhausted 3840. You'll only use the amount of 3612.5. You can see my workings that I did earlier on for machine Y hours. After you substitute the units, you'll use only 3612.5. Here you can see from the workings that I've given you. Okay, then also, yeah, the balance, if you want, you can compute that between what has been used and what was given as the 3840. There is a balance which you can call our slack. And this is a figure we had from our previous table, 22,7,500. Remember, I had already converted my figures to whole numbers without the decimal by multiplying all through by 100, okay? But it's the same if I to go back to the original measurements of the values are given. And if we have a balance, then it means the shadow price will be equivalent to 0. And that's what has been provided as the shadow price alongside the machine Y. The right-hand side constraints, we were having this when we were forming our inequalities or when we formed our LP model. Also, how much can we allow to be our increase or a decline? If we were to increase the plastic waste, because we had already exhausted, there was no balance, we allow an increase of 1,733, then it would mean our objective function would improve by that figure. I repeat, because we had already exhausted the plastic waste, let's say we have any additional amount. If we increase the units of the plastic waste by the given amount there, then it would mean our objective function will change by the same amount. It will increase. If we allow a decline in the plastic waste, for us to come up with a figure of 4,441,000, we have to use the whole 34,000. So if we allow a decrease of 6,800, then that would have the same effect on the objective function value. It will also go down. The same happening to machine X. The machine X, if we were to allow an increase of 850, the objective function would actually improve. But if we allow a decline, then it would mean the objective function would actually have its value going down. And finally, for machine Y, we need not to increase it at all reason. We haven't even exhausted. But we can say, if we decrease it by 227, what would be the effect? Then it would mean we'll still make an achievement of our 4,441,000, because even that 227 has not even been used to acquire a figure of 441,250. And that interpretation, what I've talked about, is all that you have been asked to do on Loma number 3, Loma 4, as well as Loma number 5 there. The plastic waste, if we wish to overcome that particular constraint, then what do? We increase the units by purchasing each and every kg at a price of shillings 98.125, which is given by the shadow price. And maybe tomorrow the question will be about there, something like the machine X, which was exhausting. You can say, if you want to increase, any amount would cost you how much in order to overcome that particular constraint. So that is the interpretation of the figures which are given as part of the solution as a computer output or a computer solution. Sometimes the data is given, you're the one to come up with a solution. Other times, the problem could be with a solution provided, and now you'll be required to make the contribution. So we stop there for today. In our next class, we'll look at the assignment, and I'll also create time to be able to look at the transportation problem. Probably Monday. Tomorrow I have 2 meetings. Maybe Monday we can have a session in the evening, and then I'll also require that we meet another day. But from Tuesday maybe to Friday, it will be hard for me to be meeting you at around 5. Maybe we consider to change our meeting time.